Good afternoon. My name is Jennifer Sills. Today I am going to be going over hypothesis and SPSS. First of all, what we'll be learning today is how 6 steps of hypothesis testing framework. So the first thing that we need to do before we go to SPSS, we need to ensure that my research question aligns with the test that I am planning to run. So let's go ahead and jump in here. Okay, so the first one, what I did and stuff is created some slides. We're going to be looking at hypothesis testing framework and the difference tests, and also how it applies to sample t-tests. Okay, so the first one, when we're kind of deconstructing things, what we are going to want to need to do is we are going to want to apply the verb analysis framework. The primary verb that we're going to be looking at, if you look at this research question, is there a significant difference between the mean math scores of 8th grade students and the district proficiency target of 90, at Lincoln Elementary? So what we are looking here is, first of all, we're looking at the fact that we're comparing samples of 8th grade student math scores to a known benchmark value. So here where it says primary verb, we're gonna note the difference, right? Is there a difference in the hypothesis null? We're kind of trying to determine, is there a difference in the two? The comparative verb, this is comparing the 8th grade students' math scores to the known benchmark value. The independent variable would be the district proficiency target. So this is set at 90, which is a benchmark value. This is not grouping, comparing one and the other. This is actually taking a sample, which will be the 8th grade student scores, and comparing it to what the district proficiency is. So 8th grade students and stuff, their math score, which is the dependent variable, and then for the independent variable would be compare it to the test value of 90. The DV measurement value level will be continuous ratio. So what we're doing here and stuff is we're making note that the one sample, which is what we have and stuff for 8th graders, is compared to the other value, the other known value, which would be pretty much the benchmark values. So this leads us to the single sample t-tests. Okay, so the next one that we're going to need to determine is we're going to talk about what, in steps 1 and 2, what are null hypothesis and what are the alternative hypotheses. So the null hypothesis, which is the basis is that there's no significant difference between 8th grade math scores and the target of 90. So we are trying to determine that. Do we have a difference or do we not have a difference? What the symbols here go, like where it shows here, H naught mu equals 90, it represents a null hypothesis and that there's no difference. So if we determine that there's no difference in the hypothesis between the two scores, or the benchmarks and the 8th grade math scores, then then this will show and stuff that for that and stuff. If not, then we'll be rejecting it. But this is where we're at. The next thing we have here is research alternative hypothesis. So what is our alternative hypothesis? Our alternative hypothesis shows that there is a significant difference between 8th grade math scores and the target of 90. So if there is a difference, then we'll be showing that. So for the research symbols, as I had just described, it says no significant difference between 8th grade math scores and the target of 90. If there is no significant difference, then those were the symbols and stuff. So for this one, what we have here and stuff is it shows you there's no significant difference. So 1 sub 1 and the mu does not equal 90 and stuff. So we just need to determine, was there significance or was there not a significance? Well, also what we'll need to be doing is looking at the alpha level. So the alpha level and stuff is set at 0.02. It is two-tailed. So right now we're not determining if it's like one tail or towards one side or the other. We're just trying to find out if there is a difference that exists between the two, for the benchmark and the 8th grade scoring. So the alpha we set at 0.05. This is the standard threshold in educational research. So this means that we're willing to accept a 5% risk of a type 1 error, concluding that there is a difference when actually there is not one. So the hypothesis is based on whether or not there is a significant difference between 8th grade math scores and the target of 90, and we have to determine that. The next one that we want to go over and stuff before we jump into the SPSS is that we need to check assumptions for a single sample t-test. The first thing that we need to look at is continuous dependent variable. So what we have here and stuff is a math score, and our math score is going to be on a ratio level of 0 to 100. The math is measured on a continuous ratio scale. So we have that. The next one is random sampling. So we have to note the limitation in this, and that there is not a random sampling because we're looking at the school's math scores for the 8th graders, which we have that set. So we have to note this in the limitation because it is relation to Lincoln Elementary. So again, random sampling is not randomly because we're taking it from that 8th grade set. Independence, so each of the student score is independent of the other scores. So what we have here and stuff is that we know that this independence has been met, and because every student score has their own score, whatever they earned on their math score for just the 8th graders that we're looking at. Normality. Okay, so in this one, we're going to show that it was violated by the Shapiro-Wilks. We're going to go into it, and I'll go ahead and explain. We're going to talk about whether it's a highly significant p-value or not. Again, if you notice back here, we had set that the alpha and stuff is at 0.05. So if the p-value and stuff is higher than that, then we're going to talk about how that affects things. In our sense and stuff, what we're going to do is we're going to know that it has been violated, but I'll go into greater details as we go into the SPSS, and also with the N, so we'll learn that the N is the sample value of the student, so 552. So when we open SPSS and the data, the 552 represents the actual students. Now, what we also need to look at and stuff is central limit theorem. So it's a fundamental concept in statistics that explains why the distribution of a sample tends to be normal regardless of the population distribution. And since this size is so large and robust, then that is why the sample distribution can be so large and stuff. So once we go there, I would like to go ahead and bring us into running the analysis. So now we're ready to go into SPSS. So when we're doing that, what we're looking at and stuff is the areas where the data is. So I am going to go ahead and pull up the data. I have the data right here. So this is the data view, and this is the variable view. So last time we had discussed we had gotten given data and we had to break it down. So we have all these data, they have different variables. Now what we're going to be looking at is, like I said, we're comparing the 8th grade math grades and stuff compared to the benchmark of the district. So and we'll go and look at those grades and stuff in the benchmark district of 90 to see if our students are meeting that. So when we do things here, the first thing we'll need to do is you'll need to go to data. And when you go to data, in order to play with the information and stuff, we'll need to select cases. So we're looking at grade level, so we'd hit select cases. And then we're going to go to grade level. So now we're going to hit if condition is satisfied. If. So our if is looking, first of all, would be grade level. So you would have to click on that grade level. You would bring that variable into this field, and we're going to put it, we're only going to do 8th grade. So what will we do if we're only doing 8th grade? Well, if this is the case, we would put equal 8, right? So we are going to pull up all the data for the math scores for the students that actually that are in 8th grade. So we will do that first. First, we're just looking at the grade level and hit continue, then hit OK. Okay, so when we had the data view, now we have the data view of all of this. So this was for the grade level. These are all the students that actually are in 8th grade. Okay, so the next one, what we're going to want to do is go to Analyze and Compare Means, and we're going to run a sample t-test. Now, in order to do the sample t-test, we have to decide which part of the variables are we going to be looking at. Well, in this sense, we're going to be looking at math scores. So you would put, again, our research question and stuff was looking at math scores, right, of 8th graders based on the benchmark. And so we're going to have that as this one. Now this one over here, the test value, we can go ahead and put that number as 90 as far as we're going to compare it to see if they met that means of 90. Now in regards to this and stuff, you could also, if you were looking at that, suppose it was like 92, then you would put 92. So this is just based on or 91. On what you're comparing it to in the district benchmark. In this situation, we're going to put 90. So we're going to hit OK. Okay. And then we are going to wait here. We should be able to get now in our view. Great. So what we have now and stuff is we are going to have a t-test, okay? So what our t-test is going to consist of would be, now I have 2 t-tests, just so you know, because before I had run it for 90 and I did it at 90 again, so it just shows that amount. So there's multiple things that we need to look at when we're looking at the t-test. So again, this t-test and stuff is great because it's going to allow us to see several different concepts. Now, when we're looking at these things, what we will want to do is first of all start off and look at the one sample statistics. Okay, so if we go over here and we go to one sample statistics, we have several different, we have different boxes. So we have this box, then we have another one sample test box, and then we have one sample effect sizes. So let's go ahead and look at the one sample statistics first. So the first thing that we need to do is we need to look at the N. So what is the N? Well, the N would be the number of students. So in this situation and stuff, what we're having is we have 552 8th grade students, right? That we're looking at their math scores. So the N stands for pretty much the students. So the mean, this shows what the students are making. So these students are at 86.05. So that means their mean score is 86.05, right? So these 8th graders. Well, is that above or below? Well, this and stuff would show that it is below our target of 90. So they are a little bit below, not extremely below, but a little bit below. Now the standard deviation is 10.651 and the standard error mean is 0.453. So this over here kind of shows us and stuff. It shows you the one sample statistics of the students. It shows you the mean. Now we need to see, is this going to be statistically significant difference, between the scores? So 90 versus 86.05 that we have. Well, let's go down to this one sample test. Okay, so we're looking at this one sample test here. So what we have and stuff over here is you'll see that there is a T. So this T over here, and you can see the mass score, right? And it shows based on the test value of 90. So when you look over here at the T at the mass score and stuff, we see that there is an 8-point difference, right? Negative 8.708. And then what we'll also need to do and stuff, is look at the degree of freedom. So that is how much data was able to vary based on the degree of freedom. So we have that. Now this is the next one. We are trying to determine this test. And when we're looking at the p-value, we talked about alpha. So when we talked about alpha earlier, I'm going to go back over here if I can show it to you real quick. Okay, so alpha will be set at 0.05. So when we're looking at this, is alpha set at 0.05? Is it different? Well, we have it at 0.001, right? So on this two-tailed test, it is significant, right? Because it's 0.001, and again, let me just jump back over here. The alpha level and stuff is two-tailed. So when we're looking at our two-tailed thing, we're not determining and stuff if we have we're not like determining whether or not is it this end or that end, but we're determining whether or not there was a difference. Well, there is a difference, right? There was a difference, substantial difference. So we have that significance on the two-tailed test at the p-value of 0.001. The next one and stuff is the mean difference. So if we look at this mean difference, negative 3.947, so what we see here and stuff is how far under 90 the students are scoring. So this is what they're scoring under. Not totally different, but there is that difference there. So now let's look over here. If you can see, 95% confidence interval of the difference. So if we look over here, there is no zeros. What we do see is negative 4.84 to negative 3.06. It does not show zero, so we're comfortable with the data that falls within this range. So when we have that data that falls within that range, we can kind of see how everything goes. Okay, so the next thing what we're going to do, we're fixing what we're going to do here is now see sample size. So the first thing that we're trying to evaluate, number one and stuff, is was there a significant p-value and stuff, and also for the null and stuff, we're looking at that, and then we're also looking at the Cohen's d. So Cohen's d is right down here. I'm going to go back to the slide so you can see one sample effect size. So when we're looking at this, we need to determine what is the effect? Is there an effect? Is there not an effect? So that's something that is important and stuff for us to look at. So when we're looking at Cohen's d, how you find the small effect size is you would take the mean difference, which I'm going to show you in a second, and you divide it by the standard deviation. So this one and stuff over here and stuff, that would be the standard deviation. So let me go ahead and have everything on here, and I will show you over here. So we did that. Okay, so when we're looking at the difference and stuff, we have it over here and stuff is 10.651, so that shows you Cohen's d. So what you do is you divide the mean difference, which would be over here and stuff. You would divide the mean difference, which would be negative 3.95. So it's negative 3.947, you would divide that by the stabilizer and stuff. And then what you'll have in number, you have to calculate yourself, is negative 0.37. So the Cohen, what it does is it looks at and it says, okay, if there is a difference, is the difference really going to make a huge impact? And in this situation, what we're going to have to do is analyze that. So we have to make our decision. So step 5, make a decision. So we compare the p-value to the alpha size. So since the p-value is less than the alpha, we will reject the null hypothesis, okay? So we are going to, we're stating that whether we're going to reject it, reject it. And we're also, what I want to do is report on the effect of the Cohen's d. So how we do that and stuff is over here. So Cohen's d, whether or not it has a major effect. I know usually we say we don't calculate it, but what we are looking at is the standard deviation. So you divide the mean difference. So over here, okay, so we're going to divide the mean difference, right, by the standard deviation, which is this number. So negative 3.947 divided by 10.651. Okay, so that number is resulting in negative 0.37. So this one shows that it's a small effect size. So on here, that kind of gives us an idea, well, what are we looking at? We're looking at the data and stuff. Yes, there is a difference between the students that their benchmark was 90. Did they meet it? No, but the thing is that was it significantly different? Did it affect the Cohen's d? So when we're looking at it and stuff, we need to look at all those factors. So over here, I'll go through it. Here, the test value was 90, so we know that the benchmark was set at 90. We know that we had, so T 551, that's very, very, very much close. So the small effect size was very, very small on that one. So the negative 8.708 with the p size of 0.001. So there, in regards to this, we're going to reject the null, right? Because there was a significance difference because alpha was supposed to be set at 0.05 and our p-value was 0.001. So there was also a mean difference of negative 3.95. So what that means is the student scores were lower than that 90. And if you look over here, and stuff, you know, with all of the scores and stuff, it does show you. So test value equals 90, but if you look at the first test, the mean, we can see they were about 86.05. So standard deviation was 10.651. So that's where that shows you that the mean difference between what we had and what they actually scored was that difference. There was a small effect size. So now, what we're going to want to do and stuff is know that yes, we do have these 8th graders and stuff that are on the gap. So they do have a little gap. Like I said, the mean difference was negative 3.947, so it was small. So the mean for all the 8th graders' math scores was 86.05. So this means that even though there was a difference, it was not a crazy difference, right? So so what we're gonna do here and stuff. So now what we did need to go back is determine, okay, so what are we gonna do? Are we going to reject the null? The first thing, and that is the first thing we talk about. Yes, we're going to reject the null because the p-value is 0.001 and alpha was set at 0.05. So if we look over here, as you can see, the two-sided p, 0.001, and the null value was set at 0.05, right? So because of that, because it was set, alpha value was at 0.05 and stuff, we are going to reject the null because there was a significant difference, right? So that's why we're rejecting it. And the Cohen's d and stuff, what we're doing is we are going to be taking that number and stuff for the Cohen's d. So we take the mean difference, negative 3.947, and again, I was saying we go ahead and divide it by the standard deviation, 10.651. So that number that we have is negative 0.37. So that's a Cohen showing that there was a very small effect. Yes, are we a little bit low on our numbers and stuff, but not that much, right? Only like about, like I was saying, that mean difference, negative 3.947. So we have that. And so what this means and stuff to us is that we will tell them, yes, there is a difference. We're going to reject the null because the p-value and the alpha was at 0.05. So we are rejecting the null that there was no difference because there was a highly significant p-value. And then what we're also doing is saying that the cohency, even there was a significance, what we do notice in the student scores. So if we go back to the student scores, it's not that far off, right? So we're at 90 was what the benchmark was at, and the student's eighth grade score was 86.05, right? So this is not far off from where we need to be, and that kind of shows you where we have those connections. And so, if we're connecting back to a research question, the practical significance beyond statistical significance is, yes, there is a difference and stuff, but in the Cohen's d, it was such a small effect size that it wasn't really that relative, right? So that's with statistical significance. Do we have that? Yes. So on over here and stuff, what we were trying to determine, with that was there a statistical significance? And on the two-sided p-test, there was a statistical significance. Okay, because it was supposed to, alpha was set at 0.05 and we were at 0.001. So what this means is on the graph, it is so close. Not there, but so close to that line that we were looking at. So with the p-value and stuff, it will be a highly significant p-value. As for the rest of it, that we are looking at, we'll just look back at the research question one more time. Is there a significant difference between the mean math scores of eighth grade students and the district proficiency target of 90? So that, again, that answer is, looking at this graph over here, is that with this and stuff, with the Cohens and stuff, there is a small effect size and stuff, but the p-value does show that there is a highly significant p-value. So what we want to tell principals in the future is, are we under our benchmarks? For a benchmark, are the students doing well? Do we have huge gaps or just little gaps? Well, we can say we have little gaps because the mean is at 86.05 for the eighth grade math scores, and the benchmark was at 90. So we're not too far away from it, just a little bit. And this just shows you how we run analysis and how we we rejected the null, and so what we did is, when we rejected the null and stuff, over here and stuff, what we'll look at and stuff is that we're rejecting the null, and and then for the alternate hypothesis and stuff, was saying that there was a significant difference between eighth grade math scores and the target of 90. So that's where we're at. Thank you so much. I appreciate your time. Thank you.